let's talk about the architecture of this. And I think just from a computer science point of view, it's just interesting, the architecture of how you build your app. The platform, the browser, is like an operating system that these apps are going to run on top of. And just like an operating system technically has the kernel and all these processes running under the hood, and then it has the user interface with the windows and the mouse and the menus that you interact with. So we have one, Microsoft Windows really is two parts. There's the part you can see and the part you can't. Same thing here. You get one executable that you run, and that's your browser, but the browser actually has inside of it this platform. So the platform is the kernel. It has a bunch of processes running. The browser is the thing that tells you, here's the apps you could install. Please install them. I'll install them now for you. Which one do you want to run? OK, now I'll run it for you. So it's very much like an operating system. And this is free for download, and it comes with the SDK, and you can also get it by itself soon. Not yet, but go to our website and sign up for it. Now, of course, what we want to do is build an app that can run on this platform. So here's your app. You're going to build this app to run on the platform. And your app, when you build it, has two parts. So the app has two classes that you need to write in Java. When you write an app for Swirls for this platform, you write it in Java. And it will run in a sandbox to protect the user's computer from malicious stuff you might do. And in Java, you need to write two classes that are important. You can write lots of other classes, too, if you want to, just good software engineering. But there's two that the platform cares about and will talk to. In the API, I've given you two interfaces, Java interfaces, and you have to implement those two Java interfaces. So if you're a Java programmer, all that makes sense. If you're not a Java programmer, don't worry about it. You just have to make two chunks of code, and they have to follow what I tell you to put in them. And if you follow what I tell you to put in them, then the platform can call those two and can interact with them. So you have to write a main and a state. The main is your main program. It's where your main program loop is. It's the thing that pops up windows and shows them to the user. It reads the keyboard and the mouse from the user. It does all the calculations, some of the calculations, but it does all the user interface stuff. It's your main program that makes the things happen in general. If you wanted to write a server, it's the thing that is the server that listens to a port and goes out to the internet and gets data from people. The main is your main program, but you also have to have a second thing. And that's the state. And the state, we'll go back. The state remembers whatever's in your program that's supposed to be the shared state that we're getting consensus on. So for a distributed management system, the state is the list of current sessions. That's the state. And what my main program does is it says, hey, state, I need you to add a new session. We've just started a new session. Or I need you to delete a session. So the main is going to be telling the state basically to change itself in various ways as the sessions change. If this were cryptocurrency, the state would just be how much money is in every wallet. That's it. And then the main would do the things like say, hey, please move money from this one to this one, and so on. In a game, the state is, in the game that I just showed you, the state is where are each of the 8 players on the screen, and how many points does each of the 8 players have. So the state is a fairly small amount of information, and it's the thing that we want the whole community to agree on. If you have any local information, like the user just says, I want this color scheme in the browser right now, that you store in the main. It's only the stuff that has to be shared with the whole community and agreed upon by the whole community that's in the state. But the main doesn't talk directly to the state and give it changes to make, because that'd be bad. It would only change your local copy. The whole point of state is that it's in sync between everybody. So here's how it works. Main, when it decides that something has to happen, so main perhaps has decided in a distributed session management system, we need to create a new session. The user's authenticated, I'm an IDP, I have the authority to do this, I can digitally sign it, I can convince the community to do it. It is time to officially say that session number 42 is started. And I want the state to remember that session number 42 is a real state and it's not yet logged out. What you do is you create a transaction, which is just a little string of bytes that encodes, I want state session 42 to get started, please add it to the list. What's the format? It's whatever you want. Because what happens is that transaction gets passed to the platform, which passes it back to the state. Oh, you have a pointer. It passes it to the platform, which then passes it back to the state. So the way your main changes the list of sessions is by creating a little transaction that will say, please add a new session, and it gets passed indirectly back to the state, and then the state adds that new session. And so you can use whatever format you want to encode your transaction, because you're the one who wrote the code that makes it, and you're the one who wrote the code that uses it. So whatever language you want to make up for your transactions, you can. You probably want to save bandwidth by making it fairly concise. So that's interesting architecture, that we have to split the program in two, and one half talks to the other through these transactions. On the other hand, talking from state to main, you just do method calls. You can actually access its internal variables if you want to. So say main wants to know the entire list of states, the entire list of sessions in a DSM system. If you want to, you could write in your state a method that says, hey, return the entire list of all the sessions. And main just calls that method on the state. Main has a reference to the state, and it just calls it, and it gets all those sessions. And that's it. Often in a client-server system, you have to be very careful about what data you're sending back and forth in both directions to be succinct. One great example would be in something like a game, like a multiplayer game. The client has to send the server what moves the player is making, and the server has to send back to the client the entire state of the world, which may be this big three-dimensional thing. It's gigabytes of data. And so they have to send diffs to it, and it's very complicated. In this architecture, if there's some gigantic data structure in here, main can just read it directly. Reading that giant data structure is very easy. Changing the data structure, you have to send out a transaction, and it comes in to change it. Does it make sense? You split your program into the main thing, and then you have this little shared state. You have to be careful how you change it with these transactions, but then you can read from it anytime you want, and you can just call methods and read from it. Now, why are we splitting it that way? Well, because we want consensus. I don't want to just change my state. I want to change my state in a way that everybody's state will change that way. And so when the platform gets your transaction, it passes it on to your state. But it also sends it out to this platform running on all the other computers in your community. So you set up a group of computers that are running the same app that are all in the same shared world. And anytime one of them does a transaction, it goes to all of them. And so all of them learn about the transaction. And so what's this line then? This line is where the platform tells the state the transactions you made up and the transactions that everybody else in this shared world made up. And so all the sessions will be there, the sessions you created and the sessions other people created. And then in your state object, you just implement code to enforce rules. If some people aren't allowed to create new sessions, you just don't add them to the list when they try to do it. You look at the transaction and you say, oh, that's a nice transaction, but you don't have the authority to create a session. I'm just going to ignore it. I'm not going to add it to the list of sessions. So all the rules of the community are enforced by the code that you've put in your state. That's all a rule is. It's just saying who's allowed to change the state of the world and who's not allowed to change it, and what are the rules for how it evolves over time given the events that have happened.